Alright, quick question. What's actually happening when you flip a light switch and the room just wakes up? That everyday magic is electricity, but not like lightning trapped in a wire. It's way simpler and way cooler. Think of electricity as a crowd of tiny charged particles, mostly electrons, moving through a path. In metals, electrons are like students in a hallway who are free to walk. When I push them with a pressure, they flow. That pressure is voltage. The amount of electron traffic is current, and how hard it is to move through the hallway, that's resistance. So voltage pushes, current flows, resistance resists. Ohm's law is the cheat code, V/IXR. Crank up the voltage, you can get more current. Increase resistance, current drops. It's like water in a hose, higher pressure, more flow. Thinner hose, less flow. Where do electrons even go? They don't vanish, they loop. Electricity needs a complete circuit. A source, a path, and a destination back to the source. Battery to wire, to light to wire, back to the battery. Break the loop, flow stops. That's why switches matter. AC versus DC. DC, direct current, is like traffic moving one way down a street. Batteries do DC, AC, alternating current, flips direction back and forth, like everyone switching lanes 60 times a second in the US, 50 in many other countries. Power grids use AC because it's easier to move energy long distances with less loss, using transformers to step voltage up or down. What do electrons actually do for you? They carry energy. When current flows through a phone, it powers chips. Through a toaster, it heats coils. Through a speaker, it wiggles a magnet to push air so you hear music. Same electricity, different effects depending on what it's driving. Where does the energy come from? The source. In a battery, chemistry sets up an imbalance, like a hill for electrons to roll down. In a power plant, turbines spin generators, moving magnets near coils to create voltage. That's electromagnetic induction, motion turned into electrical push. Why don't birds on power lines get zapped? Because there's almost no voltage difference across their 2 feet. They're at the same electrical height. Touch a line and the ground at the same time? Now there's a huge difference, and current wants to flow through you. Don't be that wire. 3 everyday tips. High voltage doesn't always mean high danger. Current is what harms. But high voltage can make current flow through you, so treat it like a boss fight. Insulators like plastic and rubber block flow. Conductors like copper and your salty wet skin allow it. Dry hands are safer than wet. Power, how fast energy is used, is P and consho VXI. That's why a 1000-watt microwave slaps harder than a 60-watt bulb. So electricity is not mysterious lightning juice. It's a controlled dance of charges pushed by voltage, limited by resistance, looping as current to deliver energy where you want it. Master the trio: voltage, current, resistance. And you can decode every light switch, charger, game console, and electric car. And if you want to see it in action, grab a safe battery, a resistor, and an LED. Complete the loop. Boom. Light.